This is Scott from KIG. It is May 30th, 2017. We are in the back area, our small chiller test area of KIG here in Clinton, Massachusetts. And today we're going to be doing a runoff, not my favorite spot with the paint shipping back in the corner there, that's too bad. We're going to do a runoff today of this 6-ton Riedel air-cooled chiller. Now this unit is the model PC160.01, and I got a whole plethora of numbers there, but this is a 2013. I guess the serial number 73327100004. 460 volt unit, 3-phase. So this unit is some of the recent surplus we got from Riedel. We probably had 30 or 40 units over the years from them. It's basically in brand new condition. It has been out on loan maybe a couple months to one of their customers prior. It has two Danfoss reciprocating compressors. These units, and we're going to do just a static kind of runoff or once through here before we put power to the unit. These units are originally set up to cool laser machining. What that basically means is they have a second smaller pump here, and they have a second little heat exchanger right back here that basically steals a little bit of water off the primary main water circuit. Now for this application, this is going to a customer in plastics manufacturing out in Texas, I believe, or similar to that. And we've done this many times. We do not need to use that secondary circuit. So internally in the control cabinet up here, we just disconnect the second pump and we ship it with all the ancillary stuff for that secondary circuit. But that pump's not going to be running. What that means is all your cooling is going to come through your bigger connections here, the water outlet. Okay, and these nice fittings, the red handles, those are going to come with the unit in a box. So that's going to, your water outlet and water inlet is going to go to your primary process. These two smaller ones here, which in the world of laser cutting they refer to as the DI or optic circuit, that's simply just going to be plugged. Similarly, the DI water inlet and outlet pressures aren't going to be operating, but the primary ones for the pressure water inlet and outlet will. This here is your water filling. You can fill your water tank here if you desire. Ignore this one that says DI. And similarly on the bottom here you have your two drains. The one that says DI is not functional. This one is. On the inside of the unit here, as mentioned, we have our two compressors, and those are set up to stage at certain times within the control circuit. Here is your primary tank. Okay, the secondary tank is right behind it here. That is not going to be used, nor does it need to be filled. Internally, behind my fingers here in the tank, are two little float level sensors. We have those, because those are still tied into the controls, those are wire tied in the open position. But no water or fluid is going to go through this circuit, and it's just easier for us to leave this stuff in there as opposed to removing it. So this pump here will never operate. Also, this little DI filter cartridge is just part of the smaller circuit. That's not functional, going to be functional for your operation either. In both cases, the unit has these little heaters for each one of the tanks, which is also something that you don't need to use. But for us here, for our testing, now we're going to leave them in here, but for our testing it was kind of convenient because we could turn these heaters on to give a little bit of load during our testing. But for both these, the temperatures inside the controller that control these heaters will be turned so low that they're not going to turn on. It's not going to be relevant for your application. What is relevant is your primary holding tank here, your primary raised plate heat exchanger, this blue item here, that's your solenoid valve for the hot gas bypass for capacity control, your refrigerant sight glass here, and we have two low pressure switches. One of them is for a safety, and one of them helps. One of them is to control one of the other controller functions. Then you have your high pressure switches here. One of them is for fan switching. The other one is your manual reset if you were to go into a high pressure alarm condition. Example of a high pressure alarm condition is if it just gets too hot in the building, which is highly unlikely with this type of configuration. It's a pretty healthy sized condenser coil, and I think they were rated for well above 100 F ambient temperatures. Or if your condenser coil's got dirty or something of that nature. This is your primary pump here, and this here is basically a flow control. We'll have it set at what we feel is a nominal position. And in addition to this flow control, to control the flow out to your process, there's also an internal bypass here, and that's adjustable. Okay, so if your process is too restrictive flow-wise for this chiller, we can adjust that internal bypass to direct a little bit more flow back to the heat exchanger in this chiller. This chiller here, again, it's the Riedels are amongst the most nicely engineered units we've seen. This unit here has to have the side covers on, which we have here, to provide proper airflow through the condenser coil. So video number 2 I'll start in a second after I get the side covers on, and we'll power the unit up.